All right. Right. So very good afternoon to all of you. I welcome you all on YouTube channel of Unacademy IIT-JAM. Good afternoon, Education Tech. Just quickly tell me in the comment section if my voice is audible to you. Right. Just write down in the comment section so that I can know, right, that my voice and video is working fine. All right. Right, so this is your educator, Srishti Batra, and I'm teaching Unacademy aspirants, right? I'm teaching IIT-JAM aspirants on Unacademy who are preparing for IIT-JAM chemistry for upcoming 2021 examination and 2022 examination, all right? So this particular session is whole about the Ionic Equilibrium. What we'll be doing the basic questions of Ionic Equilibrium based on buffers, all right? Fine. So let's continue with our session now. So just quickly tell me in the comment section that is my voice is audible or not, right? So that I can begin with the session. If you are present over here, just quickly tell me my voice is audible or not. All right. Fine. So now let's begin with the session. So in this particular session, what we are going to doing, right, we'll be doing the basic questions on buffer from Ionic Equilibrium, right? And these questions will help you to test your basics from Ionic Equilibrium. And this particular session is based on buffers. All right. So buffer, this is the most important concept of Ionic Equilibrium. So we'll be taking some conceptual questions on buffers, right? So if those who are present in this session, those who are attending the live session, just quickly tell me in the comment section, is my voice audible or not, right? So that we can begin with the session. Fine. So I'll be waiting for 1 more minute so that other people can also join this session, and after that we'll start with the session. All right. Yeah. So just a minute, and after that we'll start with the session. I'm again requesting Education Tech, if you're present in this session, just quickly tell me is my voice audible or not. All right, Vidansh, fine. So all of you are present in this session, fine. So just give me a thumbs up or write down something in the comment section so that I can know this my voice is audible. Fine. So is my voice audible? Right. So it's audible. Now let's continue with the session. So we'll be taking some basic questions on buffer, right? So you have this question in front of your screen, right? So I'm giving you enough time. What you have to do, you have to analyze this question and then tell me the answer, right? So there are 4 options in this particular question. So first you have to give me answer for option number A, right? So I'm giving you enough time. So just quickly solve this question because we have covered this particular part in the yesterday's lecture on plus, right? So we have covered buffer on that particular lecture. So I'll be giving you this question for practice. So quickly solve this question and tell me answer for option number A, right? So Vedansh, Milind, those who are present in this session, just quickly solve this question and give me your answers in the comment section, right? Good morning, good afternoon, Sanju. So this is a question on ionic equilibrium from the subunit buffers, right? So this is the question in front of your screen. What you have to do, you have to solve part A. All right, I'm giving you enough time. Whenever you are done with the question, just write your answer in the comment section. Otherwise, just tell me that right, you need solution for this question. All right, so I'm giving you enough time, and yes, you have to give me answer for option number A first, right? Then we'll be doing the subsequent parts. Fine. And in case of any doubt, please feel free to ask in the comment section, right? All right. So I think there is some lag in the video, right? This is live session. So this is there is some lag in the video. So please write your answers in the comment section so that I can know that you're understanding the concepts. All right. Fine. So I'm giving you enough time. Just quickly read this question properly and you have to tell me the answer for option number A. Yes, everyone. First question, first part of this question is very easy, right? This is very easy. What you have to find out, you have to find out the, right? What you have to find out, you have to find out the pH, right? And Ka value is given to you. Ka value is 10 to the power minus 5. All right. What you have to find out, you have to find out the pH for option number A. All right. So Vedansh is saying 2.30 as pH. All right. Any other answer for this question? Yes, Shri, Rajesh, right? Sanju, Milind. You have any other answer for this question? Quickly tell me your answers. This is very easy question, right? Just you have a weak acid and you have to find out the pH of weak acid. All right. Any other answer for this question? You want more time for this question? All right. So now let's see how we can solve this question. So what the question is saying, you have zero point 0.1 molar 50 ml of acetic acid is titrated with 0.1 molar NaOH solution, right? Calculate the pH. So you have to calculate the pH, and what pK is given to you, Sanku, Ka value is given to you, that is 10 to the power minus 5, all right? And what you have to find out, first option is saying you have to find out the pH of weak acetic acid, right? And what's the formula of it? Quickly everyone tell me how you can find out the H plus concentration. H plus concentration for weak acid is KAC plus KW. Under root of KAC plus KW. Is this point clear, everyone? This is the formula of acidic concentration of weak acid, right? And what is the Ka value? That is 10 to the power minus 5, all right? 10 to the power minus 5, and what is the concentration? This is 0.1 molar. All right. And what is Ka value, right? What is Kw value? That is 10 to the power minus 14, under root of 10 to the power minus 14. Now can I say this thing, right? Can I say this thing that I can neglect this particular value, because this is great, this value is greater than 10 times of this particular value, right? So this is very negligible value. So can I neglect this particular value, right? Definitely I can neglect this particular value. So now what is the H plus concentration? H plus concentration is 10 to the power minus 5 into 10 to the power minus 1, right? And under root of it, that is 10 to the power minus 6 under root, right? And what is this value now? 10 to the power minus 3. So definitely pH would be now minus log of H plus, that is 3. Is this point clear, everyone? Vedansh, this question is clear how pH is coming out as 3. Just give me a thumbs up or just write down in the comment section if this question is clear, that the answer for option number A is pH 3. Right? Answer for option number A is pH 3. All right. Is this point clear now? Right? All right. Fine. Now you have to solve option number B. Quickly solve option number B. And what option number B is saying? If 25 ml of NaOH is added in medium, so you have to find out the pH now. Right, direct nickel, right. You can calculate this directly also, right? So you have to find out the pH if 25 ml of NaOH is added in the solution. Quickly everyone do this question and tell your answers in the comment section. Right, Shri, Vedansh, Ankush, Sankho, right, Brajesh, Sanju, Milind, everyone, just give your answers for option number B. What formula, Sankho, you are saying half? It can't be done from the formula of dissociation of weak acid, that is half pKa, all right, minus half log C. All right, fine. So this is the formula of salt. Yes, Sanko, this is the formula of salt, right? Hydrolysis of salt. This question cannot be done with the direct formula. You have to apply KaC by Kw. right? KAC by KW, and here what you have to see, you have a base and a weak acid, so you have to calculate the total number of millimoles, then accordingly you have to proceed the reaction. Fine. So here you have to calculate total number of millimoles and then you have to proceed the reaction. So what the question is saying, if you are adding 25 ml, for example, you have a, right, you have a burette, right, and NaOH is coming from it, right? So how 25 ml of NaOH you are adding in beaker, right? You have a conical flask in which, in this particular conical flask, you have 50 ml of zero point 0.1 molar acetic acid. All right, and into this particular conical flask you are adding 25 ml of NaOH. Then you have to calculate the pH of final solution. All right, right. So I'm giving you enough time. Just quickly do this question. Yes, Vedant, Shri, everyone, just do this question and tell me the value of pH you are getting. Five. All right, Sankho is saying pH 5. Any other answer for this question? Yeah, I'm giving you enough time. Just analyze this question, right? We have covered all these concepts in the last class, right? Last plus course on ionic equilibrium, we have covered there all the concepts. So I think there is no problem in this question. You can take your time and just analyze each and everything and apply your basic concepts over here, right? All right. Right, so whatever you have to convey to me, just write down in the comment section, right? As this is YouTube live session, so there is some lag, so definitely write each and everything in the comment section so that I can know what exactly you are asking. All right. Till then, Sanko, you can solve option number C and D, right? Just quickly solve option number C, right, and D. Voice is not coming. Everyone just write down in the comment section, is my voice clear? Is it coming? Is it audible? All right, it's audible, right? Fine. So now let's solve this question. Fine. So everyone just be careful. All right. Just be careful with the explanation. So what you have to do, you have CH3COOH, right? You have a weak acid, right? You have 0.1 molar 50 ml of weak acid. That means how many millimoles you have for CH3COOH? You have 5 millimoles, right? You have 5 millimoles of CH3COOH, right? Just multiply this value and you'll get 5 millimoles of CH3COOH. Then you are adding 25 ml of NaOH, right? And the molarity of NaOH is 0.1. That means you have 2.5 millimoles for NaOH. This is weak acid and this is strong base, right? So obviously there is neutralization reaction and you will get CH3COO minus Na plus, right? This is here limiting reagent, right? And the stoichiometry is 1:1. That means now the reacted amount is 2.5 for NaOH, 2.5 for right, acetic acid, and the form product or of salt is 2.5 only, right? So this is now 2.5. Is this point clear, everyone? Now what you have to see, right, what you are observing, now in the reaction mixture you have a weak acid as well as you have a salt of weak acid. That means it is forming now weak acid buffer solution. Is this point clear? This is now forming weak acidic buffer solution, right? So obviously what equation you have to apply? You have to apply Henderson's equation over here, right? So pH is equals to pKa plus log salt by acid, right? Salt by acid. And here what I have told you in the last lecture, that you don't have to consider volume over here, right? Anyhow it's going to cancel out, so you don't have to consider volumes, right? So you only have to consider the number of millimoles, which is 2.5 for salt and 2.5 for acid. All right, and now this and this gets cancelled out, so now you are left with only pH is equals to pK, which is 5. Is this point clear, everyone? Just write down in the comment section if this solution is clear, that pH is equals to 5, right? And pH for first option is 3, right? Now quickly solve option number C. Now you have to apply the same concepts over here, and accordingly you have to report the pH value, right? And in the third option, what the question is saying, if 5 ml 0.1 molar H2SO4 is also added in the solution, all right? It's also added in the solution. All right. Fine. So 4.63 is one answer. Any other answer for this question? Yes, Tamanna, Vedansh, Prajesh. All right, fine. So now let's solve this question also. In case you need more time, just quickly tell me in the comment section. All right. So now let's solve this question. So what the question is saying, if 5 ml 0.1 molar H2SO4, all right, if 5 ml 0.1 molar H2SO4 is also added. Also added means you have, right, you have previous reaction mixture in which you are now adding H2SO4. That to 0.1 molar having 5 ml. Right, so now let's calculate it. Now if you're adding H plus ions, right, this is next application of buffer. If you're adding H plus ion, so H plus ion will react with acetate ion, right? H plus ion will react with acetate ion. So now this reaction will be CH3COO minus plus H plus, and it is giving you now acetic acid, right? You can write this reaction in the vice form also, right? You can write this reaction like this also, right? In the reverse form also you can write this reaction. Fine. Now what initial moles you have for acetate ion? You have 2.5, right? You have 2.5 moles for acetate ion and you have 2.5 moles for acetic acid, right? And what is the millimoles of H plus now? Yes, everyone, quickly write down in the comment section how many millimoles of H plus you have in the reaction mixture now. Just see the molarity, just see the volume and find out the number of millimoles of H2SO4. Quickly tell me how what is the number of millimoles of H plus you have in the reaction mixture now. Yes, everyone, I need answers from all of you, right? Tamanna, Mosmi, Vedansh, Brajesh, everyone tell me. How many millimoles of H plus you have in the reaction mixture, right? So how you have to calculate the H plus moles? 5 into 0.1, right? This is 0.5 and the N factor for H2SO4 is 2, right? So you have to multiply this number by 2 and it will give you 1 millimole, right? So you have 1 millimole of H plus, all right? So now let's calculate this reaction. So now what you have? You have 1 millimole for H plus and you have 2.5 millimoles for, right, acetate ion, and you have 2.5 millimoles for acetic acid. Now this will be reacted and now you are left with only 1.5 and this and now you are now getting 3.5 millimoles of acetic acid, right? Now again this is a right buffer, because this is now also a limiting reagent, so again this is forming a buffer, right? So now how you can calculate the pH value? pH is equals to pK, which is 5 log salt by acid. What is salt now? 1.5, and acid is 3.5. That means just calculate this value and you'll be getting pH somewhere around 4.6, right? This is the approximate range. You will be getting pH somewhere around 4.6, right? And I think 4.63 is the correct answer, right? 4.63 is the correct answer. Is this question clear, everyone? Just quickly tell me in the comment section. This question is clear. How you can find out the pH now? All right, fine. So now just quickly tell me the answer for D option. Quickly tell me the answer for option number D. All right, very good, Sanko. So I'm very glad that you have now calculating this question absolutely correct. So 5.63 is one possible answer. All right. All right, very good, Tamanna, very good, Nitin. Fine. So now let's calculate this question and see how we can find out this answer. Now you have, right, now you have base. All right, now you have base instead of H2SO4. That means which species will react with base? Acetic acid, right? Acetic acid will react with base and it will form acetate ions, right? It will form acetate ions. Fine. So now let's calculate number of millimoles of your base, right? So now you have 5 ml, 0.5, that is 0.5 into 2, right? So you have 1 millimole of OH minus ion. Fine. And how many millimoles of acetic acid you had in option number B? That is 2.5. All right. And now this is also 2.5. So this will react with this and it will give you 3.5 of this and 1.5 of this. That means pH is equals to pKa plus log 3.5 divided by 1.5, and the value will be somewhere around, yes everyone, 5.36. So this is the pH value you'll be getting in option number D. Is this point clear? This question is clear, everyone, that this is very important question, right? This is very important question and applicative question from buffers, and we have high chances of getting these questions in our examination, right? So is this question clear, everyone? Just give me a thumbs up or write yes in the comment section so that I can move to next question. Right? Fine. So that is the question. This is a very beautiful question. Just analyze your concept. Just revise the basic concepts of your buffer solution. Fine. Now next question is front of your screen, right? What you have to do, just quickly read this question and find the answer for this question. So just give me answers in the comment section, right? If in case my handwriting is not legible, just tell me, I'll read this question. Fine. The molarity of both acid and base is 0.1 molar. All right. Yes, so it meant you are doing titration, all right? It is the question from titration. Fine. The question is saying a weak acid after treatment with 12 ml of this much has pH this, right? After treatment, that means you have a weak acid, all right, and it is treated with 12 ml of NaOH, right? Let's take it as NaOH, right? Let's take its NaOH, right, which is having molarity of zero point 0.1, right? And the solution, this particular resulting solution has pH is equals to 5. Fine. And what the question is saying at the end point, right? At the end point, the volume of base required is 25 ml. So at end point, 27 ml of base is required. 27 ml of base is required, right? So what you have to find out? You have to find out the Ka of solution, right? You have to find out the Ka of acid. Now this question is clear, Sanko? Right? Just find out Ka and pKa, right? Just give answers for both these values, Ka also and pKa also. All right. So Tamanna is saying K is equals to 8 into 10 to the power minus 5. All right. Any other answer for this question? All right. Fine. Right. So now let's solve this question, everyone. Just be careful with the explanation. Now what you have to do in this particular question is, all right, let's solve this question. Fine. So now what you have to do, first of all, let's read the question carefully. A weak acid after treatment with 12 ml of 0.1 molar strong base has pH is equals to 5, right? That means you have a solution or you have a reaction of weak acid. So let's take CH3COOH. All right. It is now reacted with NaOH and it is giving you CH3COO minus Na plus. All right. Now what you have to do in this particular question, this NaOH, all right, this NaOH is 0.1 molar and that to 12 ml. 0.1 molar and that to 12 ml. All right. Now let's concentrate on the question. So now what you have to do, right? What you have to do in order to find the pH of this solution, right? In order to find out pH of the solution, you have to calculate the number of millimoles for CH3COOH. Is this point clear? Just write yes in the comment section if this point is clear, that in order to find out the pH of this particular solution, you have to find out, right, number of millimoles of CH3COH, that is acetic acid. Is this point clear now? Right, Sanko, that you have to find out this millimoles. Right, you have to find out this millimoles. All right, now let's find out this millimoles, and how we can find out this millimoles. Let's find out is any other information is given to us at the end point. At the end point, the volume of base required is 27 ml, right? At the end point, the volume of base required is 27 ml. So now what is end point? Right? What is end point? So can I say this thing, that number of gram equivalents of H plus is equals to number of gram equivalents of OH minus at end point? So can I use this equality at end point? Yes, everyone. Just write down in the comment section if you are clear with this equality, that at end point the number of H plus required is equals to number of OH given, right? So definitely we can use this equality. Fine. So now let's calculate this. That means what is number of gram equivalents? Number of moles into N factor for H plus All right, number of moles into n factor for OH minus. Right, so now what is number of moles for OH minus? It's already given to us, that is zero point 0.1 into 12. 0.1 right, zero point 0.1 into 12 is the number of millimoles for OH minus, and n factor is already 1, because it's not given in the question whether the base is monoprotic or right dibasic or monobasic. So what you have to consider, you have to consider 1 over here, right? So this is now, this particular thing is, this is given in the question 27 ml. So you have to take 27 ml, not 12 ml, right? You have to take 27 ml. Fine. So now that means 2.7 is the number of millimoles for OH minus ion. 2.7 is number of millimoles for OH minus ion, and n factor of H plus is also 1. So can I say this thing that number of millimoles for H plus is also 2.7? Yes, everyone. Yes, Vidansh, Milin, Nitin, everyone tell me, Tamanna, that can I say this thing that number of H plus is also 2.7 millimoles, right? So with this we concluded that H plus, right, millimoles is also 2.7. Right, H plus millimoles is also 2.7. Now the question is clear. All right, now the question is clear. You have CH3COOH, all right, plus you are adding NaOH, and it is giving you CH3COO minus Na plus. Right, number of millimoles of acetic acid is 2.7 now. Number of millimoles of this is 0.1 into 12, that is 1.2. Right, this is limiting reagent. Right, so now the left amount of acetic acid is 1.3. All right, it's 1.5, right? It's 1.5, and this amount is 1.2. This is clear now. This is 1.5 and this amount is 1.2, right? So now apply Henderson's equation. pH is equals to pKa plus log salt by acid. All right. Now what is salt? Salt is equals to 1.2 pKa plus log 1.2 by 1.5. All right, and what you have to find out, pH is already given to you, that is 5, right? Can you find now pKa? What is pKa? 5 minus log 1.2 by 1.5. Quickly everyone, just find out the value of pKa. Right, but this is weak acid, so 100% dissociation won't occur. But what you have to consider over here, Sanko, that means number of gram equivalents, right? You have to consider number of gram equivalents of acetic acid, right? So we are only considering total amount of H plus over here, right? We are only considering total amount of H plus over here, and how you can calculate that total amount by using number of gram equivalents concept. Right, what is happening at end point, whether you have weak acid or you have weak base, right? It's given in question that the molarity of base is also 0.1 and the molarity of acid is also 0.1, right? So definitely this is the way you have to find out the number of gram equivalents, and accordingly you have to substitute the value over here, and you can get the value of pK, which is coming out as, quickly tell me everyone, pK value. राइट मैम, पर हमें इस डेटा से पता चलता है कि बेस कितना यूज हुआ, and pH से हम concentration नहीं निकाल सकते. All right, so what you have to do over here, Vidansh, right? Just give me a second, right? So what you have to do over here, so right, so let me read your question first. All right, fine. So what you have to do over here, Vidansh, this condition and this condition, both conditions are different, right? These are not same conditions, these are two different stages, right? These are two different stages, so you cannot find out the value of pKa, right? You cannot find out the value of pKa. Now pK is coming as 5.09, right, Mosmi? pK is coming as 5.09, and how you can calculate Ka now? Minus log of, right, minus log. How you can calculate Ka now? This is now 10 to the power, all right, you can calculate Ka now, right? 10 to the power minus 5.09, right? This is the way you can find out Ka now. Is this point clear, everyone? Minus log of Ka is equals to Pk, which is 5.09, and Ka is equals to 10 to the power minus 5.09, right? And this is the way you can find out Ka. Is this point clear, everyone? Sanko, Tamanna, Mosmi, Vidansh, right? Nitin, everyone, this question is clear. How you can find out the value of pKa from this particular data? right? And this is the correct way of doing this question, because you have two different stages, right? You have two different conditions, and according to that you have to find out two different conditions, right? And this is the correct way of doing this particular questions. So with this we have concluded our topic on buffer, right? So we have concluded our topic on buffer. So please attempt all the homework problems that I have given you in the last lecture, right? And from tomorrow at right 10:30. From tomorrow at 10:30 a.m. we'll be starting with salt hydrolysis, right? What topic will be starting? We'll be starting with salt hydrolysis. So please revise all the given topics which I have already covered in ionic equilibrium, and at 8 a.m. we have next class on stereochemistry. So please revise stereochemistry also before upcoming class, right? So is this point clear everyone? Right? You got this question, how you can solve this question? All right, fine. So that is the way you can solve this particular question. Fine, right? So this is all about this particular session. So now how you can join this plus subscription. So those of you who will watch this recording, right, who will watch the recorded version of this particular video, how you can join the plus subscription, let's talk about that, right? So if you want to study for IIT-JAM 2021 or 2022, right, so you can just use the plus subscription. And how you can buy the plus subscription? Using my referral code, right? So this is my referral code, that is SBATRA, right? This is my referral code. Let me quickly write over here. This is my referral code, that is SBATRA, right? So this referral code will give you 10% discount, right? And it will help you in just clearing out your IIT-JAM right, examination with the personal guidance of myself, right? Now how you can just attend the special classes which are of free of cost. So just search my name, right? Just search my name, that is Srishti, over IIT-JAM category, and you will find this profile, right? Once you just search my name, you will just find this profile, and after that you can go to special class icon, and you can just just follow me on Unacademy, and after that you will be updated with the upcoming timings of the special classes, right? And this is the plus courses that I'm taking on Unacademy, right? So definitely you can take the plus subscription if you want to prepare for IIT-JAM 2021 or even 2022, right? So now this is the end of this particular session. I hope you like this session. If you like, just give this session a big thumbs up, right? And write your feedbacks in the comment section. All right, so everyone, now I am taking a leave. So I'll be meeting you with next YouTube session very soon, that I'll be telling you on my right Telegram channel. Fine, so let me quickly write my Telegram channel over here in case you want to join that Telegram channel. So this is the name of this Telegram channel, that is Unacademy SBATRA, right? This is the name of my Telegram channel, and this is my contact number. So if you want any guidance and if you want to contact me, so definitely you can just use this contact number. All right, fine. So everyone, have a good day, take care and stay safe.